number 6 says that you can describe ionic and covalent bonds. So let's take a look at this. I have two pictures here that I think that you'll find somewhat amusing. Here we have a picture of a sodium, Na atom, and its little baby here is the electron, and it says, please take him, just take him please, and the chlorine says, yep, don't mind if I do. Well, here's what's going on. This baby is being given, it's the electron, it's being given from the sodium to the chlorine. The reason? Chlorine belongs to group 7. If we look at the periodic table of elements here, you see that chlorine is over here. That's group 7. Chlorine just wants one more electron, and it'll fulfill what we call the octet rule. Sodium wants to lose one in order to have a full outer energy level, so it's trying to give it away. It's a match made in heaven. One electron is given to another electron. One electron, is given from one atom to another atom. That is the definition of an ionic bond. Okay, so this is an ionic bond. Now, what are some things that we know about ionic bonds? Well, hopefully you remember the lab that we did, and I can pull that lab up real quick. And that lab that we did was on ionic and covalent bonding, and it looked like this. And it had the long procedures, and you worked your way through it, and eventually what you got to was you got to melt these different substances, and you had to say whether or not they were had a high or low melting point. Well, hopefully you found that sodium chloride, like the compound that I just showed you here in this illustration, sodium chloride, had a high melting point. Okay, and so this is one of the things that we know is true for ionic bonds. They have a high melting point. We also know that they conduct electricity. Okay, they conduct electricity very, very well. And the third thing is these are very strong bonds. They're very difficult to break. And then when we look at covalent bonds, I have no idea what this has to do with anything, I just thought it was kind of funny. When we look at covalent bonds can be found in our organic molecules, like sugar, for example. These things have low melting points, and if you remember the lab that you did, the sugar melted, okay? It had a low melting point. It melted on a hot plate. These do not conduct electricity well, so I'm going to put non-conductors here. And non-conducting, and you know, they do conduct some electricity, and they can, and you may have even experienced that when you ran the test on your sugar that was dissolved in the water, but they don't conduct electricity particularly well, and in comparison to ionic bonds, these are weaker bonds. Alright, so basically we have 3 different properties for both ionic and covalent bonds. We have a high melting point for ionic bonds, conducting electricity well, and they're strong. And then covalent, we have the opposite, low melting point, non-conductive, and weaker bonds.